Welcome! In this lesson, you will learn how to create and save plots after running a simulation. You will also get an idea on how to create a scene and run the animation. In this practice, we will use the simple elevator.m model. Open the model and click on the Simulation tab. After the system compilation is finished, run the simulation. Click on any icon on the sketch. We can plot the parameters and the variables in the list. Drag and drop the displacement at port 1 of the counterweight to the sketch. The curve represents the moment of the counterweight mass. Select File, Save Data. We can save the plot as a data file. Type in a name, counterweight displacement, and save it. Create a default blank plot. Drag and drop the data file to a blank plot, then we can get the plot back. We can also drag other curves to the plot to make a comparison. Drag the displacement at port 1 of the cabin to the plot. The curves show a different moving direction of the two masses. Select File, Add to System, click OK, and then we can find the plot in the drop-down list of the plots. Click on the Manage button. In the dialog, we can export the plots as a .plt file. And then we can also import it back. Click Open Plots button to show the plot, and click Close Plots button to close it. Create another new plot. From Tools drop-down menu, we can set the page layout. Here we set a 2x2 layout and click OK. Let's drag 4 different variables into the plot: the mass displacements and the rope lengths. Select File, Export to Picture, to export the plot to file or to clipboard. In one word, with the plots we can have a good understanding of the system movement. In order to visualize the results better, you can also create an animation. Animation can be launched by clicking the icon in the Analysis toolbar, or selecting the animation from the drop-down list. The animation window is made of 3 parts. The right-hand part is the object tree area, a tree structure of the scene. The center part is the scene area, a 3D window with a grid in the XY plane. The left-hand part is the object inspector area. It contains the properties of the selected object. The initial information is shown in the slide. The specification lists the required parameters, such as the position, the length, and the radius. Let's start to create a scene based on the information. Put the sketch and plot window to a proper position in order to have an easy way to drag and drop. Here, we want to view the movement of the counterweight, cabin, and ropes. Counterweight. Select Add Cylinder. Choose the center of the scene to fix the cylinder, and left-click to set the center point of the cylinder base. You will be able to displace the cylinder in the scene later if necessary. Move the mouse to define the limit of the cylinder. You will see a preview of the base of your cylinder. Click the left mouse button when you have determined the radius. Determine the height you want by moving the mouse up or down. In Object Inspector window, change the name to counterweight. Set the top center coordinate position to -2, 0, 6. Set the color to blue. Set the radius to 1, and set the height to -2. Cabin. Move to Object Tree. Click on Scene and then add a new cylinder. Move to Object Inspector. Change the name to Cabin. Set the top center coordinate position to 2, 0, 2. Set the color to red. Set the radius to 1 and set the height to -2. Click on the Front View button and move the mouse wheel to make it smaller to fit the window better. Rope 1. Move to Object Tree. Click on Scene and then add a new cylinder. Move to Object Inspector. Change the name to Rope 1. Set the rope top center coordinate position to -2, 0, 7. Set the radius to 0.2 and set the height to -1. Rope 2. Move to Object Tree. Click on Scene and then add a new cylinder. Move to Object Inspector. Change the name to Rope 2. Set the rope top center coordinate position to 2, 0, 7. Set the radius to 0.2 and set the height to -5. A scene is built with objects whose behavior is managed by controllers, position, rotation, properties, colors, and so on, and channel values. The channels are linked with SimCenter ImSim result data or external data. Before we start the animation, we should post-process some values. Drag the displacement at port 1 of counterweight, the displacement at port 1 of cabin, the total length of rope 1 and the total length of rope 2 to the post-processing window respectively. Rename the title with the name counterweight top center, cabin top center, rope 1 length, and rope 2 length respectively. Modify the expression to add 2 meters to displacement and add minus before the rope length in order to fit the movement in the scene. Finally, associate the controllers in the scene with the channels. Click on counterweight in the object tree. Drag and drop the counterweight top center to the Z position channel. Click on cabin in the object tree. Drag and drop the cabin top center to the Z position channel. Click on rope 1 in the object tree. Drag and drop the rope 1 length to the height of the rope 1. Click on rope 2 in the object tree. Drag and drop the rope 2 length to the height of the rope 2. Play the animation and we can see the movements of the components.